Hey guys, welcome to Mind Your Maths. So in this video, I'm just making a tips video again. So to know certain rules when you are actually adding, subtracting, multiplying or dividing on the fractions, right? So this video is mainly because some students or some kids, they get confused between when should I take LCM or when should I do like cancelling one value from the numerator and then one value from the denominator. When do I cancel or when do I take LCM to solve any fraction problems, right? So I have written all the four of them because this is where you also, if you're confused, this is going to kind of clarify you. When should you take LCM and when should you use the cancellation method, like using a common number that can divide both denominator and the numerator, right? So let's see how. Right, you see here in this problem, this is addition, this is subtraction, this is multiplication, and this is division, right? Division, or division can be written using this operation sign as well. So it doesn't matter whether you use this or that, it's all the same. Yeah, okay. So now I'll tell you that when should you take LCM, right? If the fraction or if the problem is about addition or subtraction, right? Addition or subtraction, in this case you should take LCM for the bottom numbers, and then then just follow the steps that I'm going to do, right? When should you cancel? You should cancel when it comes to multiplication and division. So in this you can cancel picking up one number from the numerator and another number from the denominator, and then if it both can be divided using a same value, then you can simplify by the cancellation method. Yeah, so when it comes to addition and subtraction, it is LCM. When it comes to multiplication and division, it is using the cancellation method. Yeah, so this you should always remember this. Yeah, so that you will not get confused when you solve problems. Yeah, now let's see how. In this case, you need to get an LCM, right? So LCM you need to take using this method. Usually you take this way. So you straight draw this line and put both the numbers 7 and 4 and 7. You check if both the number can be divided using a same number, right? So in this case 4, yes, it can be divided using 2. But 7, no, other than 7, 1 and 7, it cannot be divided. So both the numbers do not have any common number that can divide both the numbers, right? So in this case, how do you find the LCM? Wow, yes, that's right actually. So you just multiply both of them. So 4 times 7, yes, it is 28. So the LCM is, let's write it here, LCM is how much? 28, right? So now at the denominator we have to make it to become 28, right? So now what do we do? How do we make the 4 to become 28? Yes, we multiply by 7, and because we are multiplying the denominator using 7, we have to multiply the numerator as well using the same number. Yeah, so let's do that. So here it is 28, 4 times 7, right? And here also we have to do 3 times 7, right? 3 times 7 is 21, and plus here it is 7. So now the 7 we need to make it 28. What do we do? Yes, we need to multiply using 4, and because we are multiplying at the bottom using 4, at the denominator using 4, we have to multiply at the numerator as well using the 4. So now this becomes 28 at the denominator, and here at the numerator 4 times 4 is 16, right? So now because we have same denominators, what we can do is we can take that as a common one, 28, and then add the numerators together, 21 plus 16, right? So how much that will become? Let's add 21, 16, right? 7, 3, 37. So the answer is 37 over 28, right? So that is how you do it. Yeah. So whenever it comes to fraction like this, what you should remember is that you have two apples, right? You have two apples. One is cut into 4 pieces, and out of which they have taken 3 pieces. Now another apple is cut into 7 pieces, and they have taken 4 pieces, right? Now if you add them together, this 3 piece and this 4 piece, you cannot add them together because one apple was cut into 7 pieces and this apple was cut into only 4 pieces. Obviously this one will be bigger size, this one will be smaller size, right? So that is why you have to make both apples into same size. That is why we are taking the LCM. So we can, both apples can be cut into 28 pieces. These 4 pieces can be cut into 7 pieces each, that will make 28 pieces. These 7 pieces can be further cut into 4 pieces each, that makes it 28 pieces, right? And then because we are cutting at the bottom, we have to cut at the top as well. The denominator and also the numerator we have to cut into the same number of pieces, right? So then only the size will be same at the numerator as well as in the denominator as well. Not only between these two apples, but also the pieces that was picked up, right? So that's a small tips, right? If you like it, you can use this analogy to understand why we are taking LCM, right? So LCM is mainly because we have to make the denominator as the same value. Then only we can just add, or even same thing for subtraction. So let's come to the subtraction. Now between 8 and 5, same thing, let's follow the LCM. 8, 5. Do they have any common number that can divide both of them? No, right? So what do? Yes, we just multiply both of them to get the LCM. So which is 8 times 5 is equal to how much? 40, yes. So LCM equal to 40, right? So same thing, we have to follow same here. Here we added, but here we're going to subtract. Yeah, that's all. So to make the 8 to become 40, what do? Yes, we multiply 8 by 5, right? And then because we are multiplying at the bottom, we multiply at the top as well, both numerator and the denominator. Now on this side, what do we do for this fraction? The 5 we have to make it to match the LCM. So what do? We multiply using 8, right? And because we are multiplying the 5 with 8, we have to multiply the 2 as well, the numerator and the denominator, right? So now this one will become 4 times 5 is 20 over 8 times 5 is 40, right? Minus 2. 2 times 8 is 16 over 5 times 8 is 40 again. Now because we have same denominator, now we can take the denominator common and then subtract the numbers at the numerator. 20 minus 16, which becomes how much? 20 minus 16 is 4 over 40. This is an answer, but you can further simplify it using the cancellation method, which we will learn here, right? We will learn here, but I will just use it here, or I will first come here and then come back to cancel this one. This is the answer already, but we can further simplify it. Yeah, I'll come back to this one after this, then you will understand. Yeah. Now when it comes to, right, multiplication, we are not going to take LCM for these two. No, we're not. LCM is only for addition and subtraction. When it comes to multiplication, what do is we can straight multiply all the denominator and all the numerators together. Yeah, so that way you can do it also. And also always need to pick up one value from the numerator and one value from the denominator. It can be from any fraction, but as long as you pick up one value from the numerator and one value from the denominator, this logic is right. Yeah, people sometimes get confused. I'll tell you how. But right now, let's see. Let's take this 6 and this 9, right? Both numbers can be divided using what? Yes, 3, right? So this one, 2 times 3 is 6, and this one, 3 times 3 is 9. Now you see here, this one is 3 and this one is 3 as well. One number from the numerator, one from the denominator again. See, first we took one from numerator, one from denominator, and now after we cancel that one, right, now we again go for the same thing. See here, you pick up one numerator and one denominator. So 3 we cancel for 1 time 3, and this one cancels for 1 time 3 as well. Now let's see here. So this 2 and 10, right, they can both go for 2, right? Yeah, so this is one numerator and one denominator. So this one 1 times 2, this one 5 times 2 is 10. Now you have everything, like all are cancelled, nothing can be cancelled more, right, further. So now you multiply everything at the numerator and the denominator. Here 1 times 1 is what? 1. Here 1 times 5 is 5, right? So this is the answer, right? Now people will get confused. Some students might get confused. Oh, fine, like I can see 3 here and this 6 here. Actually this both can go for 3, right? This one is 1 times 3 and this one is 2 times 3. Why can't I cancel that way? No, it is wrong. Yeah, you must always pick up one value from the numerator and one value from the denominator. It can be anywhere. There may be more multiplications, right? And 1 3 here, and that might have another number at the denominator, you know, after 5 or 6 numbers, 6 fractions, right? But if as long as everything is multiplication, you can pick up one value from the numerator and one value from the denominator to cancel it. Yeah, clear? Yeah, so if it is still not clear, please raise your hands. Yeah, and those who are watching on the YouTube, please send me an email or leave a comment so that I can explain more. Yeah, right. So this is the final answer for this multiplication. Now let's come back here. See the cancellation procedure that we just followed here. You see here, one number from the numerator, another one from the denominator. See, both can go for how much? Yeah, we can start with 2, or we can take even the 4 itself, right? See, 1 times 4 is 4, 10 times 4 is 40. So the final answer is 1 over 10. So that is the final answer, right? So that's how we simplify when it comes to the fractions. Yeah. Okay, so now let's come to the division. Very, very important that you need to remember this one, because many people get confused here. Yeah, you pay close attention to this one. Whenever it comes to division, right, division of fractions, what you can do is that you can the denominator that you have, right, instead of dividing using the denominator, if the denominator is the fraction, what you can do is you can multiply using the reciprocal value of the denominator. Now what do I mean by that? The reciprocal means just putting it in the reverse order. Reciprocal of any fraction is just putting it in a reverse order, which means if 1 by 2 or maybe 3 by 5, the reciprocal of this one is 5 by 3. Yeah, so that is how you do that. See, the 5 goes to the numerator and 3 goes to the denominator. That's what the reciprocal means. Yeah, so now let's see here. So what do we do here is that instead of dividing using the fraction, you can multiply right, using the reciprocal value of the fraction at the denominator. Now let's write it. How it will become is that 12 over 3, right, this one can be multiplied by 7 over 14, right? Got it? So this, the reciprocal value of this one is 7 over 14. Just putting it in reverse, but instead of division it will change to multiplication, right? So this is very, very important. You don't get confused, right? Okay, so now let's cancel. If there are a number that can be divided like can be, the two numbers can be divided by using the same number, which means one from numerator, another from the denominator, right? How do we do that? Let's take the 12. So this 12 and then the 14 can go for 2, right? Yes. 6 times 2 is 12, and then 7 times 2 is 14, right? Now you see here we have 7 here already, and we also have 7, one in the numerator, another one in the denominator. So we can cancel these two. 1 times 7 is 7 and 1 times 7 is 7, right? Now you see between these two, again 6 and 3 can go for 3, right? Can be divided by using 3, which means 1 times 3 is 3, 2 times 3 is 6. Now we cannot cancel anymore, so let's multiply everything, whatever we have, at the denominator all of them, and at the numerator all of them. So here 2 times 1 is 2, here 1 times 1 is 1. 2 over 1 is actually 2 itself, right? So 2 is the answer, right? Now you might have a question, oh, if I do this reciprocal multiplication, how do I know if the procedure is right or not? Okay, you might have that question, right? Okay, so let's, for those people who have that question, let me straight simplify from here itself, right? Now you see here 14 over 7. How can we simplify this one? One value in this one itself, you have one numerator and one denominator, right? So let's simplify this one. This is the bigger code, bigger the division, actual division, representing the division. So you cannot pick up one from here and one from here. No, it doesn't work that way. This is one fraction and this is another fraction. So this whole thing is a numerator, this whole thing is the denominator, right? So that is why within the numerator and denominator we again have one numerator and denominator, right? You got it? That is why you cannot pick up a value from here and then cancel directly here. No, you cannot do that straight away. Yeah. Now let's simplify here, right? We want to validate whether the 2 is correct or not, because we use reciprocal value here, right? So now if you cancel these two, right, this one 1 times 7 is 7, and this one 2 times 7 is 14, right? Okay, now here at the numerator section, here is 1 times 3 is 3, and then this one 4 times 3 is 12, right? Now at the denominator, what are we left with? 2 over 1, which means 2, right? So at the numerator, the denominator we have 2. At the numerator it is 4 over 1, which is 4 itself, right? Now here in the answer you have only, right, a numbers, right? This is another fraction, but this has a numerator and a denominator again. So now let's cancel this. Both can go for 2, right? Can be divided by 2. So 1 times 2 is 2, and 2 times 2 is 4. See, now you have 2 over 1. 2 over 1 is equal to 2. See, same answer we got, right? But this one is very, very troublesome, right? You will get confused what to cancel and all those things. That is why you always follow, the moment you see a fraction divided by another fraction, you always use this procedure to multiply using the reciprocal value of the denominator. Yeah, clear? Right? Yes. Okay. Right, so if you have any further questions on this one, please leave a comment or email me. I will make a video on that question separately so that you can understand more. Right, okay, so otherwise this is all for this video, and please subscribe to the channel and also press the bell button to get the latest videos notified to you. And thanks for watching.